Very good morning, dear students. Today we are going to discuss robotics. So, what is robotics? Okay, study of robot. And what is robot? And what is robotics? Robotics is the intersection of science, engineering, and technology that produces a machine called robots that substitute or which it is a substitute for human action. Okay, so robotics is the intersection of science, engineering, and technology that produces machines called robots. Okay, so robot substitute for human action. Okay, so we will discuss that robotics in details. Okay, so robotics, the definition of robots. Okay, robotics, there are different types of definition basically based on robotics. So robotics may be defined as the science of designing and building robots suitable for real life application. Okay, in automated manufacturing and other non-manufacturing environment, basically designing and building of robots for real life application. Okay, so where the word robot is come from. Okay, so the term robot is derived from Czech word robota. The term robot is derived from a Czech word robota, means forced laborer or slave laborer. Okay, so robot is a substitute of human action. Okay, so there are different types of definition. Okay, based on robot. Okay, so many efforts have been made by different people to define robots, but according to Robot Institute of America, now it is a Robotic Industries Association, RIA, define robot as a robot is a programmable. A robot is a programmable. Okay, multifunctional manipulator designed to move materials, parts, tools, or special devices through variable programmed motion for the performance of variety of tasks. A robot is a programmable, multifunctional, multitasking, multifunctional manipulator designed to move material, parts, tools, or special devices through variable programmed motion for the performance of a variety of tasks. Okay, so this definition is according to Robot Industries Association, RIA. Okay, so next is the laws of robotics. Okay, basically there are three types of law. Okay, which is proposed by Sir Isaac Asimov in 1940. Okay, there are three basic laws of robot which is proposed by Sir Isaac Asimov in 1940, and the zeroth law was added on later. Okay, so what are the laws of robotics? Then first law is the very simple. A robot must not harm a human being. Robot must not harm a human being or through inaction. Allow one to come to harm. Robot must not harm human being. This is the first law. Second law, a robot must always obey human beings. Second law is a robot must always obey human beings unless it is in conflict with higher order law. Okay, so a robot must always obey human beings unless it is in conflict with higher order law. The third one is a robot must protect itself from harm unless that is in conflict with the higher order law. A robot must protect itself from harm unless that. Okay, a robot must protect itself from harm unless that is in conflict with the higher order law. The last one is the zeroth law. A robot must not injure humanity or through inaction allow humanity to come to harm. There are four laws of robotics, very important laws of robotics. Okay, so next slide is the objective of using industrial robots. What are the objectives? Okay, first one is the to increase productivity. If we use robots instead of human action, okay, or we can say no, a robot is a automated device. So though in productivity of the productivity of an organization is increased. Okay, so to increase productivity, to raise the quality level of products, to raise the quality level of products. So products are manufactured automatically. Products are manufactured automatically through by the robot. So quality level of product is increased. Okay. So third one is the to minimize the labor requirement. Okay. So a labor requirement or labor shortage condition is minimized, to minimize the labor requirement. Okay, to reduce production time automatically, production process is completed automatic means, production time is reduced. Okay, to improve existing manufacturing process, robotics, no doubt it is a advanced technology. Qualitable parts are manufactured with exact time, accurate parts can manufacture. Okay, so there is a improvement of existing manufacturing process. Okay, because robot technology is a newer technology, advanced technology. Okay, so to enhance the life of production machines. Okay, so next one is the to increase the safety level of the labor by replacing them by robots. Okay, to increase the safety level of labor by replacing them by robots. Okay, so robot, so if we use a robot, automatic device, advanced technology, the quality of product is increased, accurate parts is manufactured. Okay, accurate parts are manufactured, and the production cycle is minimized. Okay, so no doubt if qualitable parts are manufactured and with a reduced production cycle, reduced production time, then customers are satisfied with this with this product, with that product. Customers are very satisfied with that product. Okay, so no doubt the productivity will be increased if we use robotics, yeah, robot. Okay, so very advanced technology, robot. Okay, so next slide is the functions of a robot. Basically, functions of robot is categorized into three groups, three areas. Functions of a robot is categorized under three areas, that is sensing, decision making and performing. Sensing, decision making and performing. Sensing. First, the robot sense the environment. First, the robot sense the environment with the device sensor. Okay, with the device sensor, robot senses the environment. Okay, then the information, then the measurable quantity that sensor can measurable quantity, the measurable quantity sensed by the sensor from the environment is sent to the servo mechanism. Sensor senses the environment and send the information to the servo mechanism, to the servo mechanism. Okay, where the decision making is performed. Okay, so decision making is the second function. Decision making based on the information received from the sensor. Okay, so after the decision making, the drives allowed to create motion. The drives allowed to create motions, or actuators or drives allows to the necessary motions. Okay, that is performing the tasks decided. Okay, so sensing, decision making, and performing, there are three functions of a robot. Okay, so next slide is types of industrial robot. Okay, there are different types of industrial robot according to coordinate system, or other different types, but in your syllabus basically there are two types of industrial robot: general purpose robot and special purpose robot. Okay, general purpose robot and special purpose robot. These general purpose robots are adapted according to the user's requirement. These general purpose robots are adapted according to the user's requirement. Okay, by attaching end effector or fingers. Okay, so requirement requirement of work like part picking operation, welding operation, spray painting, etc, etc. For this type of operation, special for this type of operation, according to requirement, the general purpose robots are adopted. Okay, so it is basically used for mass production and cheaper. Okay, the parts are readily available in market. Okay, so this is general purpose robot. Special purpose robots are basically designed for special work. Okay, so in next slide, a special purpose robot, these robots are tailor made to specific job requirement. Okay, so specific job requirement, special operation, it is basically used for special operations. Okay. This type of robots are particularly designed for a specific requirement, specific task. Okay, so these robots are specially designed for such specific needs. Okay, so the design and manufacturing of this type of robots consumes a lot of time. Okay, and the parts are cannot be readily available in market. Okay, they are costly. Okay, so they cannot be manufactured in mass scale. Okay, so it is basically designed for specific needs, specific type of operation, for specific type of task, or specific type of requirement. These type of robots are made. Okay, so these are the two types of industrial robots, and broadly general purpose robot and special purpose robot. Okay, so next is the robotic system. Okay, next is the robotic system. So robotic system, or we can say robotic system. So robot system, so a robot, it is also called industrial robot or robot arm. Okay, robot is also called robotic manipulator or robot arm. Okay, so robot a robot is also called robot arm or robot manipulator. Okay, so basically robot composed of different types of components. Okay, so we will discuss the components of robot. First one is the base. Okay, first one is the base. It can be fixed, it can be mobile. Okay, second one is the manipulator arm. Okay, manipulator arm. What is the function of manipulator arm? The manipulator arm moves with a number of degrees of freedom. Okay, there are 6 degrees of freedom. Okay, so with a number of degrees of freedom of movement, the manipulator arm with a specific specified reach in the coordinate system to attain a design in workspace. Okay, so manipulator arm freely moves with the number of degrees of freedom. Okay, so next is the gripper and end effector, okay, which is used for holding the workpiece or tool. Okay, so gripper or end effector, which grips or which holds the workpiece or tool. Okay, so gripper and or end effector, it is used for holding a piece or a tool depending upon the application of robot. Okay, so next is the drives. Okay, we already discussed about drives, which is also known as actuator. Okay, so they move manipulator arm and end effector to the exact position. Okay, so drives generally moves the manipulator arm and end effector. Okay, it is also known as actuator. Okay, then is the control system. Okay, so a control system which controls the robotic actions. Okay, so a suitable control system with or without servo mechanism for sending signals to the drives. Okay, control system, as we discussed already. So a control system, a suitable control system with or without servo mechanism for sending signal to the drives. Control systems, after receiving the signals from sensor, it send the signal to the drives. Okay, so control system with or without servo mechanism for sending signal to the drives or permit to storage of programs and data for desired path planning with required speed and good accuracy. Control system controls the robotic action. Okay, so it receives signal from sensor and sending that signal to the drives. Okay, so then after so control system, the controller, next one is the controller. It is provided with interfacing units, okay, connected to the external equipment in the outside world. There is a interfacing units. Okay, so it deliver commands to the actuators. Okay, so from the control system, controllers are deliver commands to the actuator with the help of hardware and software support. Okay, so these are the different components of robot. Okay, so next is the sensor. So sensor, already we discussed about sensor. Sensor sense the environment. Okay, so sensor sense the environment, working environment. Okay, so it has a dual function. Sensor perform dual functions. Okay, so first is the to act as a feedback device to direct further action of the manipulator arm and the end effector or gripper. It receives it receives the signal. It receives the signal from environment and sent to the control system, and after that again it is a feedback device to direct further action of the manipulator arm and the end effector. So next was the to interact with robots working environment. Okay, ये तुम्हारा working it senses the working environment. Okay, or to act as a feedback devices also. Okay, so there are there are two functions of that sensor. Okay, so next is the degrees of freedom. Okay, so degrees of freedom of robot manipulator arm, very important. Okay, there are 6 basic motions of degrees of freedom. Okay, vertical motion, okay, vertical motion, radial motion, okay, rotary motion, and roll motion, pitch motion, and yaw motion. Okay, there are 6 degrees of freedom. Okay, so there are 6 degrees of freedom. So we next class we discussed this degrees of freedom. What is vertical motion? What is horizontal? What is vertical motion? What is rotational motion? Okay, what is radial motion? and about what is pitch motion, what is roll motion, and what is yaw motion. Okay, so next class we will discuss this type of degrees of freedom. Okay, for today's class, thank you so much. Okay.